In the previous video, we gone through these hardware configurations, and now we can actually go to the programming. So here you can see the programming blocks. Inside the programming blocks, you can see the OB1 or the organization block 1, or it's called the main programming block. So I'm going to the OB1 or the main programming block. You can see that will be by default the programming language will be ladder. So here you can see this is my OB1 or the organization block 1, and here we have the network 1. The network 1 means we are actually programming or placing the IOs right here, and let me show you how to place the IOs. So here if you want to see the favorites, you can add this in this box, or you can take the contacts and coil from here also. So let me show you how to put the contacts and coils and address it, and also the branching. Here I am placing by clicking on the network, placing a contact and placing a coil also. Okay, I just placed a contact and a coil. So I just feeding the inputs as I0.0, simply I0.0, and hit enter, and that will be fed as I0.0. that will be the tag 1. Okay, and this will be the Q0.0, enter, that will be tag 2. If you want to change that tags or tag names, you can go to the PLC tags right here and show all tags, and you can see the types of tags. You can change the name. If it is the Boolean input I0.0, it's a switch or the on switch. I type it as on, and this could be an output or a motor. So this is the on button, and the Q0.0 is a motor. And you can actually go to switch to the main block right here. While you open a tag, it will be placed, that tab will be placed right here. So that renamed as on and the motor. So let's see how to run this. First thing first, we can go and compile this. If you want to compile, we don't have to compile for every time. If you compile, that will be better, and you can actually download this program to the device. Okay, we are actually downloading this program to the device and load it. So that program has been loaded, and we can actually monitor the progress right here. You can click here and we can monitor the progress. And you can see I'm taking my simulation back and don't have to close that. And I'm closing the other things not in use. I'm inserting an input variable for giving the inputs, and inserting an output variable for watching the outputs right here. So here you can see the run and run P modes, two modes other than the stop mode for the controller. I'm making it in the run mode. Run mode means it's in the normal run time. The run P means if you are switching into run P, we can actually again manipulate the program and download that again and again. That is a run P mode. So I'm making in the run P mode and making the I0.0 on again, and you get the Q0, and that is the I0 and Q0. Simply you can turn it on and monitor here and control here also, here in the simulation windows also. Okay, that is the normal way of programming. Okay, in the normal way of simulating. And now I'm going to show you a couple of more things. I'm going offline and changing some little more things. I'm changing it to, here I am clicking on the leftmost end and making a DOL starter. Here I have to open a new branch. Here I just got a new branch and put a contact and drag and drop to the other end to here. So we can branch this contact right here, and I'm naming that as, for latching, that will be Q0.0. So that's it. So in the name of motor, that could be latched, and here I am using an NC contact for the stop button. Not here, I'm dragging and dropping here. Okay, right here. In this Siemens, we have a property that we can change the contacts whichever we want right here. That we can make it to the NC, not contact, or the negation contact, or the rising edge and the falling edge contacts. So I'm using an NC contact right here. and name it as I0.1. I0.1, and we can go to the PLC tags. Here I just got one more tag that I'm making it as stop. Stop, and coming back to the main, and on, stop, and the motor. 3 tags are used, and we can download this file simply. And you have to keep in mind, you have to overwrite this previous program, and that has been loaded, and we can directly, we don't have to go online. While you click on this monitoring mode, that will be going online automatically, so we don't have to bother about that. So for the latching, you can see I0.0 will be the start button, on and off. That means press and release. It's a push button for starting the motor. That is the default starter concept. And you can go to the I0.1 for stopping that, on and off. So that is the I/O addressing for the Siemens, and we can examine several more contacts and coils. So I'm getting back to offline mode and deleting these stuffs on, and we can go to the changing this coil into a set coil. Okay, making it a set coil. Set, and putting another contact, that will be I0.1, that will be an NO contact. I0.1, that means the stop button. That will do the work for the resetting the contact. Let me show you another coil, the reset. That will be the same address, Q0.0, that is the motor. So only this set and reset, we can repeat the same address, not in the normal coils. It's against the PLC rules. So in the set and reset, we can repeat the output address. So I'm loading that. Load, and going online, taking my simulation, and you can see the progress. So here I am making it on, and the Q0 is not on right here because I'm using the same contacts. It's making it on and off simultaneously. So I have my trouble in my program. This will be I0.1. I0.1. Okay, that's the stop button. Sorry about that. So I'm downloading it again, overwriting, and going to the monitor and taking my simulation back. So when I turn it on, that will be turned on, and when I turn it off, turn the input off. That's actually latching. That's actually holding the output. That is a set contact. If you want to reset that or unlatch it, you can turn the I0.1 to trigger the reset coil. So going, the output is gone. So set and reset. That is a set and reset coil. Set and reset. This is the basic things we can examine through these contacts and coils. We can change the contacts as well as the coil also. If you are using the pulse contacts, and if you are using a normal coil, that will be equal to, and I'm deleting this network. If you are using a normal coil, and if you are using a rising edge contact right here, say P means a rising edge contact. The rising edge contact does need a memory, that will be M0.0. I'm using a virtual memory. Inside the PLC we have a memory to hold the value, and let me show you what is a rising edge contact. The rising edge contact means that will be only turned on and off. Okay, that will be on and off, and I cannot see my output because it only transfers one single pulse. That is called the pulse, only the rising pulse. Okay, when turning it on, it only produces the rising edge pulse. That's why we are not able to see this. It's only turning on, the Q0 is turning on in only 100 milliseconds. So because that we cannot see it properly. For that kind of application, we are actually using the set. Okay, for catching that kind of high speed bits, we are using the set. So let me show you. So we are at runtime and I'm making it on and off, and you can see the output is turned on. You can see the Q0 is turned on. That catch the rising edge. When it turns on, that caught the rising edge. So we can go to see what is the falling edge. So I'm making it the falling edge. It's N negating. It actually catches the falling edge. When I turn it on, there is no output. When I turn it off, when the input is turned off, we get the output. Let's see. So it's in the previous state. So I'm making it off by manual. So I can turn my input on right here. It's a falling edge pulse. Turn my input on. I'm not getting any output. When I turn it off, you can see we get my output. That is the falling edge. During the rising of the input, there is no output. During the falling of the input, we get the output. That is the rising and falling edge contact. So these are the types of contacts. In the next session, we will be learning about the timers and counters, and we will be getting too much fun into the programming.